let's find the exact values of some trig functions for these 45-degree reference angles. So the first one is 45 degrees, which is pi over 4. Next was 135 degrees, or 3 pi over 4. Now notice that I just said 45-degree reference angle because the reference angle is the angle it makes with the x-axis between 0 and 90, so that's 45 degrees. Same thing here, 225 degrees is 5 pi over 4, but it still makes a 45-degree angle with the x-axis. Same thing here, 315 degrees, or 7 pi over 4. So the way to do this is first you want to observe that this distance is 1, and then we can draw in the vertical and horizontal distances. And we'll go ahead and label this x, and this is y, and we've created a right triangle. So we know from that the Pythagorean theorem tells us that x squared plus y squared equals 1. But the great thing about this triangle is this is a 45, 45, or pi over 4 degree, This is a 45, 45, 90 triangle, or in radians, pi over 4, pi over 4, pi over 2 triangle, which means it is isosceles. In an isosceles triangle, two of the sides across from the same angles have the same length. So in this case, we have x equals y. So if we come down here and do some algebra, we have x squared plus y squared equals 1. But x equals y, so we really have x squared plus x squared equals 1. So 2x squared equals 1, or x squared equals 1/2. So now square root both sides. X equals plus or minus square root of 1 over 2. However, in this case, we know that x is positive because we can see we're in quadrant 1, so we don't really need the negative or the plus or minus here. We just know it's positive. So now write this, square root of 1 over root 2. Square root of 1 is 1, so we get 1 over root 2. Now in every math class, for reasons that have historical accuracy but don't apply to us too much anymore, but tradition is tradition after all, we're going to rationalize the denominator. So multiply this by square root of 2 over square root of 2. To rationalize it, root 2 over root 2 is 2, and 1 times root 2 is root 2. So we just found the x-coordinate at this point here, corresponding to an angle of 45 degrees, or pi over 4 is root 2 over 2, and the cosine of the angle is the x-coordinate. So cosine of 45 degrees, or pi over 4, is root 2 over 2. Sine of pi over 4 is the y-coordinate. We already said there that x equals y, so it's the same thing. It's also root 2 over 2. Now, to finish up these other angles, observe that we have, in essence, the same triangle. These are supposed to line up perfectly, so just pretend it does. Pretend that my drawing is 100% accurate and those line up. So each one of these has a hypotenuse of 1 and an x and a y where x equals y, so you go through the math on all of these. The only thing you need to watch out for are these negative signs. So in other words, we have the same triangle 4 times here. It's just sometimes the x is positive, sometimes the x is negative, sometimes the y is positive, sometimes the y is negative. So just fill in root 2 over 2 and watch your plus or minus signs for the rest of these. So that's about the size of it. In quadrant 1, x and y are both positive. In quadrant 2, x is negative, y is positive. In quadrant 3, x and y are both negative. In quadrant 4, x is positive, y is negative. So that's about all there is to that. You'll want to memorize these angles, 45 is pi over 4, and these other ones, and the root 2 over 2 relationship as well.